find out where this is continuous, first we're going to look for where this thing's undefined. Because remember, our very first rule of continuity, our very first condition, is that the function must be defined if it's continuous. So to find out where it's defined, we just look and see, in this case, if we're dividing by 0 anywhere. So we have this 1 over x on the inside here. So as long as x is not 0, 1 over x will be a real number. Sine of that number will also be a real number. And then x will be a real number as well. So this thing should be defined everywhere except for 0. So that's no problem. And we also know that, just from our continuity rules, that this function is continuous everywhere it's defined. So since it's continuous everywhere it's defined, and it's defined everywhere except for 0, then it must be continuous everywhere except for 0. So that's what we're going to write. G of x is continuous on, and you could write this several ways. I'll write it like this first. Negative infinity to 0, union with 0 to infinity. This says all numbers from negative infinity up to 0, but not including 0, and then all numbers from 0 to infinity, not including 0. So you could write it like this. You could also write it like this on the reals, except for x cannot be 0. That's fine. You could write it like this for x less than 0 and x greater than 0. I guess we'd have to use a union sign for that. This, we can't really say and. Numbers aren't less than 0 and greater than 0. So we use the or sign, union. Either one of these would be fine to write where this thing's continuous. Basically, you're saying that it's continuous everywhere except for 0. So x cannot be 0, continuous everywhere else.